Hello, everyone. February 26th. Again, I think it's an addiction. I finished work about 10 minutes ago. 10 minutes ago. And today was supposed to be the day that I come home early, which I did. I mean, not much earlier than, I think maybe 20 minutes earlier than yesterday. And I should be spending a lot of time reading today. But then, I was planning on the work I need to do, and I thought 2 hours would be enough. But then you start doing it, and then I don't know how many hours. I just kept going on and on. This is, I think I complain every day, right? I complain every day, but nothing changes. I feel like it's my problem at this point. Absolutely, I think it's my problem. All right, what do we have today? Length of longest Fibonacci subsequence. A sequence is Fibonacci-like if more than 3, and the third one is equal to the previous 2. For all I plus 2 small or equal to n, given a strictly increasing array of positive integers forming a sequence, return the length of the longest Fibonacci-like subsequence. If one does not exist, return 0. A subsequence is... Oh, it's a subsequence. Return the length of the longest. 1, 2, 3, 5, 8. Yes. Okay, the longest subsequence. I feel like we can just brute force this. Not really brute force it. Hold on. So 1, 2, 3, 4, 5, 6, 7, 8. So we can start from. So the length of the Fibonacci sequence starting from something, or we can say ending at this. The longest, the ending at this is 1. The longest ending I hear. So it has to be 3. Wait, hold on. The longest it ends at. So I can say, give me 2, right? So I'll find the previous one. So like the longest ending at 5 is going to be 4. So the longest ending at 8, I can check for 7. The longest ending at 7. Well, because it has to be something, so it has to be 1, 7, 8. Right? Therefore, once I go for this and I'm looking at here, right? So it's the longest subsequence. Oh, I mean, technically we can just look for it. Wait, no, hold on. The longest subsequence ending at, so I have to give me 2, right? So if I have 7 and 1, then it's the longest subsequence ending at 1. Right? And then I choose 7, then I can go to 8. So we have to go the longest subsequence ending at, so if I have really xi plus 1 and xi plus 2, the longest ending at this one, I will search for every single one, And from here, I can get to this one. So it's the longest ending at here, because that does not affect this. The longest ending at xi, right? And then I have this, so because this one is deterministic, right? There's nothing you can do about it. So in this case, when I look at 7, the longest ending is one shall be 1 by itself, right? Ending at 1 is 1. So I add 2, so it will be 3. The longest ending at 8 with 7 is 3. The longest at here is also 3. The longest, so for each one, I go, longest ending at 5, that'll be 3. Longest ending at 3. Now longest ending at 3 is going to be 3. So this will be 5. Right? Longest at 4, I don't have because it's larger than this one, so I don't do it anymore. And it's strictly increasing, so I have reverse, right? I can have a map. I can have a map, so I can immediately know which position it is. And not really position, it's the longest, right? Okay. So basically, we start with everybody as 1, right? We start with everybody as 1, and we need to start from 3, from this number, right? So this number, I will go minus this. So I go this. So I go here. Right? If it doesn't exist, like if it's a negative number, then it will become a 0, right? So it will become a 0. So if it does not exist, right? If it does not exist, then we don't do it. All right, so let's try this one. 1, 3, 7, 11, 12, 14, 18. Okay, so we start from here, 7. So we need to try to find 7. 7 minus 3 is 4. 4 is larger than this, so it doesn't exist. So 7 is still 1. So basically 1 is 1, 3. Oh, I actually can. So this is 1, 1, 1. 11 minus 7 is 4. We don't have 4. 11 minus 3 is 8. So this is also 1. Now 12. 12 minus 11. So this actually has 3. So this is actually 3. And 12 minus 7 is 5. We don't have 5. 14. 2. We don't have 3. So that's 3. 18. 4. 18. 6. 18. 7. So that's 3 as well. So the answer is 3. Yep, I think that is the solution. Again, not very hard, and which is good. Maybe we can do it in, how about set a goal of 5 minutes. All right, let's see, 5 minutes. Can we do this in 5 minutes? So we need a map, right? An ordered map, int, and int, we call it dp. So we can say dpv is equal to Oh, index. Nah, it has to be value. The length of the longest Fibonacci subsequence ending at value v. Right. Okay. So we can say for a of array dpa equal to 1. All right. And then int rest is 0 for I0, no, I2, I smaller than array dot size I plus plus. And we say if and for int j equal to I minus 1, j larger equal to 0, and array j array I minus array j, right, must be smaller than array j, because it's equal or bigger than, it's a no-go. And then j minus minus, right, because we walk to the left. Int diff is array I minus array j, right? And large equal to 0. Array I minus array j, it will always be larger equal than 0. Yeah, it's whenever it's, yeah, so we say if dp dot contains diff, alright, if dp dot contains diff, then we say dp array I shall equal to maximum dp array I and dp diff plus 2. Right, and then we'll go through everything once we're done. We say rest shall equal to max rest and then dp array I. So at the end, we'll return is rest is large equal to 3 because it has to be, right? It has to be. Otherwise, return 0. It's 873. Use dp. Where? Hey, hold on. Right, and for each array I, we iterate through all array j, where j is smaller than I, and choose the one with the and form fib subsequence. Keep track of the longest obtained, or longest possible. So this is O(n) squared. Right, we can try. Might not be the fastest, but I think it will work. And proven wrong. Immediately, it doesn't work. That was interesting. Okay, I did not expect this to happen. Can we make it smaller? For example, let's just do this. Does it work? Huh. It doesn't work for the big case, it does work for the smaller case. So how about we use this? Let's try it. If we can shrink it, definitely. Nope. Alright, I think this is a very special case. How about we just get somewhere in the middle? Can we get somewhere in the middle? So usually that's how I do, right? So we have kind of 3 different ways to slice the problem. We get the front, we get the end, and we get the middle. If neither of them works, like this case, then I think we just need to do it. 7. How do you find 7? Well, let's take a look at this. It's not that bad. 2, 4, 5, 6, 7, 8, 11, 13, 14, 15, 21, 22, and 34. Okay. So we say 1, 1. This is a 1. This is 3 because 6 minus 4 is 2, right? 7, 7, 5 is 3, and 8, A6 is 3, 11, 11, 8 is 3, 11, this is 4, so this gives us 3, and 11, 6 is 5, right? Thirteen, 11 is 2. 13, 8 is 5. 37 is 6. So now we're talking about 5. This will be 5. Because of 13, 7, right? 6, 7, no, 13, 7, 6, 4, 2. 13, 7, 6, 4, 2, right? That's 5. 14, 3, 6, right? So we get 5, 7. Okay, so now we have 5. That's my answer. 15, 15, 13 is 2. So that's a 3. 4, that's a 3. 15, 8. 15, 8 is 7. Right, so that's a 5. 21 is a 6, it's already 5. 7, that's a 5. 8, that's a 5. 10, I don't have a 10. 22. 22, we have 7, 8, 9, that's still 5. It's 34. Thirty-four minus 22 is what? 34 minus 22 is 11. This is 11. 12. This is 8. This is 19. Huh? What in the world? Right, this is 11. No, it's 12. My bad. This is 12. No, this is 13. That's 7. 34 minus 21 is 13. How did I not get to... Oh, the answer is 5. What? I have 34. And then 21. 13, right? And then... and then 7. Wait, hold on. 13. How does 13 get a 5? I say 13 minus 7 is 6. So we have 6. And we have 4 and 2. Oh, I was wrong. 2 plus 4 is 6, but 4 plus 6 is not equal to 7. Wait a second. Okay, your way is not right. Damn. We have to redo it. Yeah, so we only satisfy these two adds to this, right? But then we need to say 21 minus 13. That is 8. So this can only go to 8. Right? This will only go to 8. And minus 8. And 13 minus 8 is only can go to 5. That's it. 5, 8, 13, 21, 34. So the DP shall be ending at this position with the previous. So it's kind of a a map of a map with the previous, right? We're ending at something with the previous. So we're ending at 8, but the previous is 5. I got 3. Ending at this with the previous, we got the other one. So in this case, we're ending at 34, right? And then we try. Previous is 22, so we need to find ending at 22 with a previous 12. We don't have. Okay, so we skip. Ending at 20, and we have 21. Then we need to say ending at 21 with the previous 13, how much it is. And we'll see ending at 21 with the previous 13, it should be 4, so this will be 5. Okay, I think I need to redo this, and then it's going to be, I think, a 2D. Right? It's a 2D. So we can say ending at this, right? with a previous this. So basically we start with 3, so we just say ending at this, so we say ending at here with a previous, so everybody will be 1 to start with. Not necessarily. Everybody will be 0. Everybody start with 0, right? But how do we get started? Ending at, everybody should be -1, right? Everybody is -1. So we say ending at this position, right, with the previous, so ending at this position, then we go here, right? That's the pair. And now we should say ending at here. So we say dp this with that, right, with that. And should I say it doesn't exist, right? It does not exist. Then, yeah, we don't do it. So, and then we find the next one. Does not exist, so this will be still 1. So, does not exist, which means ending at this position with the previous, we don't know, will be, yeah, it just doesn't exist. Now we say ending at here with the previous ending at here, right? So we look for the previous one, right? So we need to find ending at 5 with the previous is 1. It does not exist, right? It does not exist, so we skip. Then we ending at 4 with the previous is 2, right? We're ending at 4 with the previous 2. That shall give you 2. Ending at 4, but the previous is 2. Ending at here with the previous. So ending at 4 with previous 2, right? So ending at 5 with the previous 4, and ending at 5 with the previous 2. That should all give you ending at 5. So as we go through, so ending at 6 with previous 5 and at 7. Yeah. So these pairs, we need to form all these pairs, right? So ending at, now we say ending at 6. Now ending at 6 and previous 5, we'll set that as equal to 2. But then ending at 6 with previous 5, we'll check. Ending at 6 with previous 5 depends on ending at 5 with the previous 1. And it does not exist, then ending at 6 with previous 5 is going to be 2. Right? It's going to be 2. Or ending at 5 with previous anything, at least is going to be 1. Okay? At least is going to be 1. And then we say ending at 6 with previous 5. So I check for ending at 5 with the previous 1. They give me 1, so that will give me 2. and ending at 6 with previous 4, so we are ending at 4 with previous 2, and this depends on ending at 4 with previous 2. Now ending at 4 with previous 2 will be ending at 2 with previous 2, right? Ending at 2 with previous 2. Ending at 4 with previous 2 is 2. And ending at 2, so yeah, every pair is 2. Now, that's not every pair is 2. We need to find ending at 2 with previous 2. So ending at 2 with a previous that's bigger than this value is always going to return 1, just itself, all right? Or if a previous, it does not exist, so it will always be 1. So if we do start with everybody, it's 1. Right, we do start with everybody is 1. And yeah, we start with everybody is 1. So I have 4 with previous 2, and then this will give me 1, so this 1 plus 1, so I have 4 previous 2 become 2. And I have 5 with previous 4 will give me 2. Because I had 2 with previous 2 is also 1. I had 2 with the previous 3, like previous, a bigger one will always be 1. It's just like if it's bigger, equal to, we always just return 1. So I have 4, 5, previous 4, then we'll go and have 4 with the previous 1. And that will give me a 1 as well. Or if it does not exist, right? If it does not exist. So now we say ending at 5, a previous 2, that's a 3, so that will also be, right? So, because what I want is to establish, right? I just want to establish ending at 7, ending at 6, places 5. So we need to look for ending at 5 with the previous 1. And I check if 1 is in it, 1 is not in it, so that's just gonna be 2, right? So this will be 2, and this, and I have 4, 2, for 2 exists, and we find its index, and I check it out, and I put it there. So it's slightly different. So this will be not DP. So this will be V2I, A2I, right? A2I. And what I need is I equals 0, I smaller than n, I plus plus. I need a mapping, so we say a to I, array I will equal to I, right? So we have the mapping, and then we need dp, and dp should be a vector of size n. Well, I think it's this dp with size n, and each one will be a vector of size n and value 1, right? And then we'll start from 1. Okay, we start from 1, and then this will just be larger equal to 0. Okay, diff is equal to this. If a2 I contains diff, right? If it contains diff, we'll do something. Then we'll say dp ij, right? Because I do the j equal to, because this ij only happens at this once, right? I will not update again. So ij shall equal to, shall plus equal to, because I already have I. So I need to do dp j with a to I diff, right? There's a diff. So like we're starting from the j position, then we get to the other position. So this gives me the maximum, right? The maximum you can form from there. That's dpij. And then if it does not contain, else, right? Else. If it does not contain, then we say dpij is plus equal 1, because we can have size of 2, right? Size of 2. And once we go through, we'll do this, and this is going to be in fact, we'll go through every single one, and I'll do it here. We say res shall equal to, and it's td max res and the dpij. It's like from here we map to here, here map to here, here we map every single one. And so dpij is the max length fib sequence, subsequence, right, ending at array I with the previous value being array j. Right, dpij shall equal to 1 plus dpj, and then index of array I minus array j, right? If array I minus array j is not in the array, we default the value to 1. we default this value, right? To 1. Okay, that's different algorithm. Okay, let's try it again. Well, this time we got it. 390 and 20.30. 390? What? Well, we solved it, so that was good, but I wonder, like, how do we make it faster? Well, I mean, I am going through them one by one, right? And I was wondering if it's possible that we don't have to go through them one by one. How do you not go through them one by one? Because you don't know what the difference will be, right? So you have to prepare. So you have to go through them one by one. I do not know, but we solved this, so we can actually see our previous submission. So a previous submission, we succeed in one go, and then we have a good result. Let's see, brute force. Brute force is, oh. I did not think of this at all. We give a set. We'll start. Start with the first two. And keep finding next Fibonacci. You are kidding me. You are kidding me. This is literally just trying to find all of them. And I'm here trying to DP this shit. This is just brute force. You start from one and just keep going through and see if you can get it. It has a log m. Why log m? Because it grows exponentially. So you will look, at most 43 times. Okay, that's actually yeah, so that's that. All right. DP. O(n) squared. I'm pretty sure this is how we do it. Value to index. That's our A to I. Right? And oh, I can avoid doing this. I wonder if that's gonna make a difference. Diff. Hold on. I feel like it might make a difference. So I'll put this one here. Right? And say 2i raise 0 equal to 0 because I don't do 0. So we can reduce 1. I'm not sure. You want to try? maybe this one's faster. Yep, it's faster. We avoid one call. Is it much faster? Nope, but it is faster. Optimize the DP. Flow, we're doing away. We don't have this anymore. 2 pointers to find pairs that sum to array this. So current. So we need to find 2 pointers that sum up to this. So I'll start is smaller to end. So we have the pair. If the pair is larger than, then we move end. If it's smaller, then we move start. Else we find a valid, we'll update. So end and a current. Okay, and a current. So we say it's different from mine, but it's okay. And current will equal to start end plus 1. And once we fit it, and we'll move in. Ooh, that is interesting. That is actually very, very interesting. And we get a max length. Max length we get is and a current. And why plus 2? Include first 2 numbers. Well, because we start with 0. Right? We start with 0. We should start with 2. We should start with 2. Okay, this is pretty smart. I agree. This is pretty smart. Because all we want is we have the current one we're setting as the end, right? So we know this is the end. Then we need to find the previous 2 that adds up to this, right? So when we find the previous 2 that adds up to this, then the length of the current 2 will be the previous 2 plus 1. It's pretty darn good. The way that we're doing is we're looking at the current 2, right? And then we find the difference. So we can immediately find the previous one. Then we can find the previous 2. So it's slightly different, but for our method to work, we need an extra map to mapping from the value to the index. Otherwise, we cannot get there. But here with 2 pointers, you don't need that because you immediately identify using 2 pointer to quickly identify. Yeah, because you move on both sides. So you take ON to identify the pairs without extra memory. Wow, this is pretty good. This is pretty good. This is a 2 pointer thing. It's pretty good. Okay, and now I need to think about why. Like, how do you figure out that, wow, this problem can use 2 pointers? I think 2 hints. One it's Fibonacci, so there are, always recurring sum, right? Two sum. It's like a recurring two sum problem. So that's one hint. Another important hint is it's strictly increasing. Because it's increasing, so you're able to do this part, right? This part is only possible because it's increasing. If it's not increasing, then it's simply not possible, right? It's not possible because it's increasing, so you can say, yeah, if it's too big, then we have to reduce on the right hand side. If it's too small, then we have to increase on the left hand side. That type of thing, right? If it's too big, yeah, I guess you move both towards the center. Smart. It's pretty smart. But at least I think this one shall be able to get. All right, that will be it. That will be it. I don't have any Ghana to implement this. Yeah, I read it, I nod along. Yeah, that's a good solution. I'm pretty sure this is how I did this one. Official solution. Not exactly. Not exactly. I mean, it's Python, so we can just use a dict. Right? We don't even need to do the translation. Right? We don't even need to do a translation. Well, that's fine. All right, that'll be it. I'll see you guys tomorrow. Adios.